Okay, so for the first one here, 10 to the 7th times 10 to the 12th, what do we get? 10 to the 19th. When we are multiplying exponents with the same base, we add the powers. 7 plus 12 is 19. So here, 10 to the 11th divided by 10 to the 4th is 10 to the 7th. When we divide exponents with the same base, we subtract powers. 10 to the 8th to the power of 5 is 10 to the 40th. When we have an exponent and we take it to another power, we multiply the powers. This one's a two-stepper. We have to do what's inside the parentheses first. 10 to the 4th divided by 10 to the 9th. 10 to the negative 5th, the power of negative 5. 10 to the negative 5th to the negative 5th, 25th. Negative 5 times negative 5 is a positive 25. Number 5 here, I'm actually going to scroll up and I'm going to use my little tool here to make a little more space. So, when we multiply numbers in scientific notation, we multiply the counts. 4.5 times 7.5 is 31.5. We also multiply the names. 10 to the negative 11th times 10 to the 5th. What's negative 11 plus 5? Negative 6. What's wrong with this number right now? Yeah. There's 2 digits in front of the decimal point. We've got to move the decimal point over. Make that 3.15. 4.2 times 7.5. So now this number changed, our power has to change. This number got smaller, the power has to get larger, yes. So negative 6 plus 1, negative 5. Over here, we're dividing. And when we divide the counts. 2.21 divided by 2.6. 0.85. 10 to the, then we divide the names. 10 to the 12th divided by 10 to the 7th is 10 to the 5th. 12 minus 7 is 5. Of course, what's wrong there? Yeah, there's a 0 in front of the decimal, so we've got to move the decimal point over to make it 8.5. Now the number got larger, so the power gets smaller. 10 to the 4th. Very good. Power gets smaller. Down here, the 5th power, we have to take the 2.1 to the 5th power, which gives us 40.84. 10 to the 8th to the 5th power is 10 to the 40th. And then, of course, we still need to move that 4.084 times 10. Is it going to be 39 or 41? 41. This number got smaller, the power gets larger. Square root. What's the square root of 4.41? 2.1. Square root of 10 to the 14th. The roots, you divide the power. So this is a square root is 2, so it's going to be 10 to the 7th. What do you think? Ready for it?
Do you happen to have 4 AAA batteries I could buy off?
So what we're going to talk about today, our new topic today, is measurement. And to understand measurement, you need to understand a little bit about how it developed. A measurement actually came from a need to communicate. You know, if 2 people are building something and they want to build them exactly the same, if they're in the same room, it's not so bad. They can just, walk over to each other and compare. So, they can just walk over and compare, but if one of them's down the hall or across town, they need some way to communicate those sizes so that they're getting things the same. Like, let's say we need to build something that's the size of this piece of paper. Well, I could do this. I take my pen and I could go, okay, there's 1, 2, about 2.5 pens. So I could send a message to you saying, hey, what you need to build is 2.5 pens long. The problem is, so it gets to you and you take your pen and you go, okay, so there's 1, 2, well, your 2.5 pens is about this much longer. So there's two assumptions that must be made in measurement. One is that whatever we're measuring with, both people have them. So we both had a pen. That worked out well. But the other assumption is that they have to be pretty close to, if not exactly the same size. These were not. The red one is about 3/4 of an inch longer than the black one. So it didn't work out real well in that case. So what they started to do for measurement, for size, for lengths at least, is they used parts of the body. So we're going to start out talking about standard measurement, because that's where measurement really started. What's that? Actually, it originated with anybody's foot. But yeah, we'll get to that.
I thought they standardized it all.
Hang in there, and we'll get to that part. So anyway, standard measurement, standard length we're going to talk about first. What's the shortest unit of length that we use in our standard measuring system? That's metric. The inch. The inch came from the distance from the end of a man's thumb to the point of his first knuckle. Pretty much everybody had at least one thumb, and they are relatively close to the same from person to person. First knuckle. So tip of the thumb, first knuckle is right there. That's an inch.
Let's get big hands.
From person to person, there wasn't a lot of variation. And you got to remember, this was, thousands of years ago, and the average height of a man was like 5'4", 5'3". So, I mean, the shorter they are, the smaller their hands are, and the less variation there is in their hands. But obviously, yes, it wasn't exactly the same from person to person. Larger than an inch, we have the foot. Okay, the foot, of course, 1 foot contains how many inches? 12 inches. Now, obviously, your foot is from the end of your longest toe to the back of your heel. If you were to check, most people's feet would be considerably bigger than a foot right now. I believe, what is a 12-inch foot is considered to be like a size 9 or something like that.
Really?
Yeah, most feet are bigger than a size 9. Anyway, you had mentioned the standardizing of the inch and the foot. It was actually in the 400s or 500s, King Edward declared his thumb and his foot were going to be the official inch and foot of the land and everything else. And that became a trend. And so different kings around different places made that same declaration. For my land, my thumb is the official inch and whatever. And as you mentioned, as different kings came to power and they took over, you did change all those lengths. So King Edward making that declaration was a very egotistical act, but it had some huge benefits to measurement as it evolved. First of all, if I wanted to measure the height of this wall, what unit would I use? Probably use the feet, right? But if I were going to measure that in feet, I'd get to about here with some serious stretching, but there's no way I'm getting to the top of that unless I saw my foot off at the ankle, is there? So a foot did not work well for measuring heights. A foot, because your feet are near the ground, was used for measuring things near the ground. So to measure the height of that wall, they had different units. They used the hand. A hand was actually the width of your hand at the base of the fingers, right here. It's about 4 inches. Now, to this day, they still use hands for measuring the height of livestock, horses, sheep, cows, just because it's tradition. But I couldn't get my foot up there, so we had to have something we could get vertically. Your hands were something you could stack up vertically and measure vertical things. Now, you got to keep the thumb out of it, remember. But yeah, you could stack them up and measure heights with it. You didn't have to try to get your leg up that far off the ground. King Edward declaring his foot to be the official foot, well, now they came in and they marked his foot off on pieces of wood, and they cut those pieces of wood and passed them out for people to use. So now I had this stick, and I didn't have to get my foot up there. I just took this stick and moved it up the wall to measure it. The second big advancement that made was, once they had a standardized unit, if I took this and I moved it to measure here, I'm going to have to actually make that a different color. It won't let me move it. So if I'm measuring it with that unit there, I take it and I'm going to move it. Okay, there's 1, 2, 3. Now here I'm able to get it pretty close because it leaves a shadow when I move it. But if you're just sliding it along, there's variance in where it stopped and where you start the next one. Every time you move it, there's a little bit of error introduced there. So what they did is, hey, to make this a little more exact and to make it quicker, I'm going to mark it on here, move it, mark it again, and move it, mark it, mark it. And so all I have to do is hold that up there and count the marks. In fact, eventually they got smart and they even numbered the marks. And that was the origins of the first rulers. Until they standardized measurement by King Edward making that declaration, the idea of a ruler never would have worked because it's your foot that you're measuring with, not a block of something. Using 2 blocks worked as well, but then eventually they settled on, let's just mark this stick and use this stick, which is a huge advancement. There are other units in there that have kind of disappeared because of the standardization of measurement. Obviously, King Edward did not have 12 of his inches in his foot. That came a few hundred years later where they adjusted those lengths. When they decided, no, we're not going to change with every ruler, we're going to keep them the same. They adjusted those lengths so there's 12 inches in a foot. Because up until that point, if you measured something in feet and I measured something in inches, we had no way of comparing which was longer. There was no correlation. Each single unit stood on its own. And that also allowed us then to get, once that was done, that standardization was done and that equivalency was created, then we were able to get rid of some of our other units, like the cubit. You know what a cubit is? Cubit was from the point of your longest finger to the point of your elbow. Now, most people, a cubit is now a little bit longer than that now, but back then it was about 16 inches. Anything that we know of that uses 16 inches a lot? Joist spacings in a house, stud spacings in a house. That was a carpenter's unit. They used their arm to set it down and mark out and lay out pieces of a house. So the carpenter with short arms built really sturdy but expensive houses, right? Because a foot wasn't real exact, they couldn't use that up until the point where they got this conversion between feet and inches, so then they could use, okay, well, we can use 1 foot 4 inches or 16 inches or whatever. And then they were able to get rid of the cubit because they didn't need it anymore. Longer than a foot, what unit do we have that we use? A yard. How many feet are in a yard? 3 feet. A lot of people think of the yard as being the length of a man's stride, and that is approximately a yard, but that's not where it came from. The yard actually came from, it's a tailor's unit, from the end of your outstretched hand to either the center of your chest or the tip of your nose. That's a yard of fabric. You grab the fabric, you pull it out, that's a yard. Grab it here and pull it out again, that's 2 yards, and so on. And of course, King Edward declared his yard was the official yard, and there weren't 3 of his feet. That was adjusted later. Now, there is, longer than a yard, there's another unit called a fathom. Anybody heard of a fathom? A fathom was for navigation. That was the shallowest depth that most of your major boats could actually navigate through without running aground. A fathom actually was they'd take the tallest sailor, they'd throw him overboard. And if he touched bottom and his head was still sticking out of the water, it was too shallow to navigate. Hopefully they tied a rope around him and pulled him back in afterwards. But
hey, go see if we're too shallow.
there you go, hit, jump. Oh, sorry about that rock. Hopefully there weren't gators. But anyway, the fathom wasn't used anymore because they could just use feet or whatever. They also used ropes with weights on them and tied them in knots. Well, they marked off the knots on the rope. Then were 1 fathom, 2 fathom, so on. Anyway, bigger than a yard, but one that's kind of obscure, but we're going to still use it. It's called a rod. 1 rod is 5.5 yards or 16.5 feet. Well, a rod is actually a shepherd's tool. Shepherd has a rod and a staff. Now the staff is that big hook, kind of like little Bo Peep has, the big hook. And the staff was used for hooking them around the neck so you could shear the wool or detain them to give them medical care or whatever. The rod itself was a big stick. That's very big. it was a defensive weapon. If wolves or wild animals attacked the flock, they'd use that stick to actually fight off the animals. And literally, they took a sapling tree, they cut it off and debranched it, and that's what they used for a rod. That's kind of, 16 and a half feet, that's more than about double the height of this ceiling. So that's a pretty healthy ceiling. The thing about if you're fighting off a wolf with nothing but a stick, you do want a little bit of distance.
Mm-hmm.
Where the rod became used for measurement. Let's say I have some sheep and Nathan has some sheep, and they go down in the valley to spend the day and eat. At the end of the day, I say, hey, I had 12 sheep. Nathan's like, well, I had 14 sheep, and there's only 20 sheep down there. One or both of us is lying. And there's most likely going to be a fight, and Nathan's going to get hurt and go to the hospital, and I end up with all the sheep. But anyway, to avoid those disputes, in cattle and horses, they use branding. Sheep, that didn't work so well for a couple reasons. One, their skin was a little more sensitive. It was hard to brand it without doing permanent damage. Second, their wool grows out thick enough that you wouldn't see the brand anyway. And third, and not least, wool is slightly flammable. So think about that for a minute. So branding was not a great option. So what they came up with is, Nathan and I would pick a landmark. Maybe it's a big tree. I would say, okay, we're going to use this tree. From this tree, we're going to mark it out. So I'd lay my rod on the ground. That's 1. Nathan would put his rod on it. I'd take mine and flip it over. 3. We measure out, okay, 40 rods this way, 120 rods this way. That's my pasture land. Then we measured out, okay, same size over there. That's your pasture land. To this day, if you look at the legal description for most plots of land, the legal description, the survey is actually done in rods. We'll get to that in a couple of days. The area measurements in acres. Larger than a rod. There's furlongs. We're going to jump up to a mile though. A furlong was actually the distance that most horses could run at full speed without getting winded before you had to slow down. It's about 1/8 of a mile. So really only about 220, 230 yards is about all that a horse can run without getting winded at full speed. That's why you see the long races, like the 1.5 miles or whatever. They're not running full speed. They're pacing themselves. But those are also thoroughbreds too. They have a lot more strength and endurance than your average horse. Right. A mile is how many feet? 5,280. How many yards?
I don't know.
1,760. So if I want to convert, let's say we have 5 feet and I want to turn it into inches, most of you know that you're just going to do what? Multiply by 12, get 60 inches. But if you didn't know that, what you could do is this: 5 feet over 1, make it a fraction. And then we're going to do like our fractions. We're going to get cross-canceling to work here. We're getting rid of feet, so I'm going to put feet on bottom so they cancel out, and I'm going into inches. And my equivalency is 1 foot equals 12 inches. Now you look at this fraction I just made here. It doesn't look like it, but it's really equal to 1, because 12 inches and 1 foot are the same value. So this is just like changing the name of a fraction. So the feet here will cross cancel out. 5 times 12 inches is 60 inches. 1 times 1 is 1, so 60 inches over 1 is just 60 inches, which is what we had up there. Well, feet and inches are units that we know well enough that we don't really need to use a conversion. Well, let's say I give you 99 feet and ask you how many rods that is. Anybody know how to convert feet to rods? Most likely not. So if we do 99 feet over 1, what unit has to go on bottom here? No. So we're getting rid of feet, so we're going to put feet on bottom. We're going into rods. The relationship is 1 rod is 16.5 feet. So the feet cancel out. 99 times 1 rod is 99 rods. On bottom, 1 times 16.5 is 16.5. And we divide. 99 divided by 16.5 is 6 rods. Make sense? So this is what we call, the standard system is what we call an evolved system. It developed over time. Sometimes it's called the developed system as well. It was not planned out. It just, as needs arose, they met those needs. You know, they needed to communicate length, so they used something to measure length. At some point, they decided it would be nice if they could fit them together, so they changed the length so 12 inches made a foot, and so on. It's very clumsy because it was never really planned out. They just kind of forced these units together to make them work. The metric system is what we call a planned system. It was actually developed in the 1880s, 1890s, so it's about 130 years old right now. And we'd been using the standard system for literally thousands of years. So they took the standard system and they looked at its strengths and they kept those strengths, but then they looked at the weaknesses, the things that were clumsy and confusing, and they tried to fix them. They tried to create a system that didn't have those weaknesses. One of those weaknesses was, 3 feet in a yard, 12 inches in a foot, 16 and a half feet in a rod, those odd conversions. So the way they fixed that was there's only one unit of measurement in each metric measurement. So meter is the only unit of length, abbreviated M. If you needed to measure something smaller than a meter, they use metric prefixes. Deci stands for 1/10. So decimeter, which is abbreviated DM, is 1/10 of a meter. Centi stands for 100th. So cm, which is a centimeter, is 100th of a meter. Milli is 1/1000th. So a millimeter is 1,000th of a meter. Now they didn't go every 10 after that. This year they went 1/10th, 100th, 1,000th. They skipped 1/10,000th and 100,000th. They went straight to 1/millionth, which is micro. Now M was already used for milli, so for micrometer, they use the Greek letter mu. Looks like a big U with a tail on it. Now, for like the medical fields, they use micrograms and microliters a lot. And the medical field, everything is keyed into the computer. So since there is no mu key on the computer, they use MC for micro. So MCM would be a micrometer. Then you can keep going. There's nano, pico, femto that are smaller. You hear a lot, about 4 or 5 years ago, you used to hear a lot about nanoscience and nanotechnology. All that really is talking about the science of things that are really, really small. The size of an atom is about a nanometer. So you're talking about things that are about the size of an atom. If you want to go larger than a meter, deca is 10. Now DM was used for decimeter, so it's DAM for decameter. Hecto is 100. So a hectometer, which is HM, is 100 meters. Kilo is 1,000. So KM is a kilometer, or 1,000 meters. And then again, we skipped 10,000 and 100,000. Jump to 1 million, which is mega. Notice I spelt mega with a capital M, so the abbreviation for megameter is a capital M followed by a little m. It's a million meters. Don't use the megameter so much because, well, a megameter, a million meters or 1,000 kilometers, it's only 25,000 kilometers around the equator of the Earth. So a megameter just really isn't a practical unit on Earth's measurement. For like interstellar travel, they use the giga would be a billion, tera would be a trillion, and so on. Those units get used for interstellar travel and stuff like that.
Is that deca with a K?
That's with a K, yes. To do our conversion, since everything is multiplying or dividing by 10, each movement on the chart is just a decimal place. So if I want to go from 4.2 meters into centimeters, well, from meters to centimeters is 1, 2 spots on the chart. My decimal point has moved 1, 2 spots, 420 centimeters. So converting in the metric system is just moving the decimal point. If you have that chart down, you can use that chart to move the decimal point. Now, in reality, on this chart, certain units don't get used. The standard unit gets used, meters, and for pretty much all of our other types, it's this way. Milli gets used, and kilo gets used. I mean, you almost never hear of hecto and deca anymore. Deci, you never hear of. Now, in the United States, the centimeter gets used a lot, only because that's the closest thing that there is to an inch in the metric system. The inch is so ingrained in us that we tend to use the centimeter. But if you go to Europe and places that are more ingrained with the metric system, they actually use millimeters instead of centimeters for most things. When we start talking about other units, these are the three that get used: the standard unit, then the kilo, and the milli. Like deciliters will get used for medical testing and stuff. If they test your cholesterol and say your cholesterol is a 190, that's 190 milligrams of triglyceride per deciliter of blood. So it's 1/10 of a liter of blood. So the metric system being planned out makes it a lot easier to use. The meter itself is slightly larger than a yard. And I always thought that it wouldn't have been really nice if they just made the meter a yard and gone from there. Well, we talked about that problem of different countries, different rulers saying this is the official foot and this is the official yard. Well, what ended up happening is over time, some different countries had different feet and different yards, and all those standard measurements were different from one country to the next. Made international trade very difficult. The meter actually is equal to the Swiss yard. The metric system was developed in Switzerland, so the meter is equal to the Swiss yard. With that, we're going to let you guys try some homework. I'm going to actually give you a packet, and in this packet, it's going to be page 237, 1 through 12, and page 265, 6 through 14. So I'll grab this packet for you right now. So it's really kind of fascinating when you think about the idea of measurement having developed over hundreds of years into a system. And they just sat down in a few months and developed a new measuring system and a metric system to replace it. What's that? Time flies when you're having fun, doesn't it? It's fun for me. The first one I'm going to hand out to you is a conversion sheet. And there's one conversion I got to talk to you about. On the front side, bottom left, where it says customary units of volume measure, it says 1 cubic foot equals 1. It looks like 1.728. That's really a comma. That's 1 comma 728. It says 1,728. Here's the packet then that the homework is in. I'll let you guys have our last 6 minutes to get started on the homework.